I was just having a sip of water. And on this water bottle, I noticed that there is a specific label. And I was wondering, I wonder how many of these labels I could print on a piece of paper this big. I suppose what I would have to do is calculate the area, or find the area of this label, find the area of this piece of paper, and see how many little areas of the label could fit on this big piece of paper. And folk, that's exactly what we're going to be doing in this session. We're going to be discussing this whole topic of area. Before we get to complicated examples like that, though, we need to look at the basics. So let's start this session off straight away by trying to define what this whole term area really means. So here is a explanation. It says area is the quantity that expresses the extent of a two-dimensional figure or shape. Oh my giddy aunt, that is just so confusing. So I've made it a little bit simpler for you. And I've said this: area is the space that a flat figure takes up. Okay? For example, this piece of paper. There is an area. It's a flat piece of paper, flat dimension, okay, just two-dimensional. It's got a length, it's got a breadth, cool, and we're able to calculate the area of that. Now, please remember, area is measured in units squared. And for you folk, what we would probably measure area in is either meters squared, centimeters squared, meters squared, or even kilometers squared. Let's have a look here at some formulas that you may require when doing this section on area. So I could ask us to calculate the area of a rectangular shape. And area, quite simply, for a rectangle is just length times breadth, or length times the width. A square is also a rectangle, isn't it? So we could also say that the area for a square is length times breadth. Here it is. But we know that the length and the breadth are the same. Look here, the length and the width are exactly the same. So we could actually say that a square is length times length, or length squared. Personally, I just say, you know what? A square is like a rectangle, so just say length times breadth. The fact that the length and the breadth are the same thing is absolutely fine. Then we get a triangle. And our triangle, or formula for the triangle is half times base times, and I want us to look at this, perpendicular height. Let's have a look at this triangle. This triangle has a perpendicular height. In other words, it's the height from the base to the highest point. But it's the height at 90 degrees to that base. It is not this height over here, okay? That is like a slant height. It's not this height, because that's like a slant height. In fact, it's not even a proper height. Height is when I stand up straight from the ground to the top of my head, okay? I can't lean at an angle, because if I lean at an angle, my height is kind of going weird, okay? Then I've got a weird height. I've got to stand up straight. And my perpendicular height is the height that stands up straight. Finally, we also could ask you how to find the area of a circle. And we use a formula that says pi times r squared, or pi times the radius squared. Okay, let's now take all this stuff and let us try and incorporate it in real questions. So, using the appropriate formula from the given table, and we showed you that table earlier, calculate the areas of the following three shapes. They want the answer in centimeters squared. So before I even start the question, I'm going to make sure all my units are in centimeters. It does warn us, it says diagrams are not drawn to scale, and that's not a problem because they're giving us the measurement anyway. Now, when I look at the shape I have a rectangular shape. I know that area for any rectangle is length times my breadth, or length times my width. My length is going to be 6 centimeters and my breadth is 5 centimeters. Okay, let's just get a color here quickly. 5 centimeters. Now 6 times 5 is 30 and my answer is centimeters squared. Centimeters times centimeters, centimeters squared. And you know you're calculating area, and because you're calculating area, your units have to be squared. So what does 30 centimeters squared actually mean? It means that if I take a little block, 1 centimeter high, 1 centimeter across, okay, and I would call that 1 centimeter squared. So if I took a little 1 centimeter block and 1 centimeter down, that is 1 centimeter by 1 centimeter. Now 30 centimeters squared tells me I can fit 30 of these little blocks inside that whole patio. Okay, that's what centimeter squared really is about. Okay, how many little centimeters could I fit in here? Okay, next question. We get given a triangle, and remember we said the area of a triangle is equal to a half times the base times the perpendicular height. Not any height, it's got to be that height that's at 90 degrees to the base. A half we know is a half. Now my base is 4 centimeters. My height is 12 centimeters. So I'm just filling in all these values over here. My calculator now we're going to take, and we are going to work that out. And I know, in fact, I don't even need a calculator for this one. A half times 4 is 2. 2 times 12, 24 centimeters squared. Got it? Cool. Let's have a look at the next example. The next example says this. We got to calculate the area of the circle. Now the area of a circle is pi times r squared. Pi we know is 3,142. Radius is 1 centimeter. I know that 1, and we're squaring it, eh? I know that 1 times 1 is going to give me 1. And so 1 times 3,142 is 3,142 centimeters squared. Easy, eh? Now what I'm going to do is we're going to take this just a step further, and we are going to look at the same sort of problems, but now we're going to start mixing shapes together, and let's see what actually happens here. All right, first one. Determine the area of each of the following, and we give you this weird and wonderful shape. Now, when I look at that shape, guys, I look at it and say, geez, I don't know what that shape is. I'm clueless. We've been dealing with rectangles, with squares, with triangles, with circles. That is something weird. But what I can do with this shape is I can break it up. Let's have a look here. I'm going to try and get us a nice straight line. I'm going to put a line from there all the way down there. So in other words, I now have a rectangle over here and I have a rectangle over here. So I can find the area of one rectangle, find the area of another rectangle, and add the two together. So when I look at this, I'm going to say the area, okay, for my first one is length times breadth. What is the length? The length of this is 16 centimeters. My breadth is 6 centimeters. Okay. Now, I'm now going to multiply and say 16 times 6. 6 sixes, we know 36. 6 ones are 6, 96 centimeters. Not just centimeters, but centimeters squared. Why? We're dealing in area. Now we look at this little block. And again, it's a rectangle. And I know the formula for a rectangle is length times breadth or length times width. Now, my breadth, I can see here, is 3 centimeters. However, I have a slight problem, and my problem is I don't know the length of this line, but I can calculate it. Let's have a look. This whole line here is 20 centimeters. Can we see that? This line is 16 centimeters. So if this part's 16 over here, and the whole thing's 20, that must be 4 centimeters. So I've now got 4 centimeters. We multiply out. 4 times 3 is 12, and because it's area, it's centimeters squared. So what's the total area? My total area now is going to be, and I'm going to write that, total area is going to be 96 centimeters squared plus 12 centimeters squared. I'm going to land up then with 108 centimeters squared. Interesting, isn't it? Now, please take note that when I did this, I've shown the examiner all my working. I haven't just done things in my head and slapped down an answer. I've shown everything. Why have I shown everything? Because when my examiner marks this, he's going to come along and he's going to say, right, length times breadth. He knew that. I'm going to give him a mark because he knew that and he knew that answer. Okay? He knew how to say 16 times 6. Over here, this is very good because he was able to calculate what that length was 4 centimeters. He's worked out that answer. He knew he had to add those two figures, and he got the final answer. So he gets 6 marks. Now imagine if I did that in my head and I made a careless mistake somewhere, okay? And suddenly I got 107 centimeters. I got this, 96, I got that 12 all in my head. I said 96 plus 12 and I got 107. And I just write 107 down. I would get 0. But if I show what I've done and I add this incorrectly, I would still get 1, 2, 3, 4, 5 out of 6. Got to show the working. Let's have a look at another example. Now over here, I have a weird and wonderful looking shape. It's actually a semicircle. In other words, half a circle. Now folk, I know that when I'm calculating area for a circle, I'm going to say area is equal to pi times r squared. But this is not a full circle. It's half a circle. So I'm going to take that result and multiply it by a half. Always remember to do this. Equals pi, we will be told, is 3,142. My radius. Now folk, what am I given over here? I'm given a diameter. Why? Because it's from the one end of the circle to the other end of the circle. So the radius must be half of that. So if I go 12,5 and I divide it by 2, I'm going to get 6,25 centimeters. So I'm going to multiply it by 6,25 centimeters, but remember, I've got to square it and then multiply by a half. Now, folk, 2 major errors that happen in matric papers. Number 1, students forget to square the radius. Remember, it's r squared. Got to square it. And then the second thing that students forget is to multiply it by a half because I have half a circle. Okay? So now, 3,142 times 6,25 squared. I'm going to bring out a calculator because my brain is just not going to do this properly. So we say 3.142 multiplied, I'm going to open brackets, 6.25, close brackets, and I'm squaring that, and then I'm going to multiply it by half or 0.5. My answer then gives me this whopping 61,3671875. I'm going to round it to 2 decimal places, 61,37. Okay, 61,37 centimeters squared. Why centimeters squared? Because folk, we're dealing with area. Another example quickly. Aha, now life is getting interesting. Over here, I have this weird looking shape. Again, folk, if I were now to draw a line and I were to break this up, and that's exactly what I'm going to do over here, I'm going to say, well, actually, I have a rectangle over here in that area. And what do I have here? A semicircle. So I know that the area for a rectangle is length times breadth. The area for a semicircle is pi times r squared, but I've got half of it because it's half a circle. When I look at my rectangle, I know that I have a length of 18 centimeters and I have a breadth of 12 centimeters. We're going to take out our calculator and do this. Out comes the calculator, and we say 18, multiply that by 12, and I get an answer of 216. 216 what? Centimeters squared. Over here, 3,142 multiply by my radius. Now, folks, I don't know the distance from the center point to the end here, but I do know this whole blue line is 18 centimeters. So 18 centimeters is the diameter. Why diameter? It goes from the one part of the circle all the way down to the other edge of the circle. So my radius must be half of that. And half of 18 we know is 9, and we've got to remember to square it and then multiply that by a half. So again, I'm going to do it on my calculator. I'm going to say 3.142, multiply that by 9 squared, multiply that by a half, or 1,5. Okay, I'm going to sometimes use 0,5, sometimes use a half, because some people like putting 0,5 and other people like putting a half. Equals, and there's my answer, 127,25. So 127,25 centimeters squared. Now, what's the total area? The total area, we're going to add the two up. I've got 216 centimeters squared. I'm going to add 127,25 centimeters squared. And out comes the calculator again. And we say 216 plus 127.25 equals, and my answer is 343,25 centimeters squared. That's not difficult at all, is it? Of course it's not. But we're now going to take this and apply it to a real life situation. Consider the shape below, which illustrates the dimensions of a pool within a fenced area. The pool is rectangular in shape with an added kiddie semicircle area. Okay, so here I have a whole fence around a pool. This whole area here, obviously, this is a swimming pool, and here is a little kiddie swimming pool part. And then all this other area is going to be grass. How do I do this? My question, I could have several questions. First one could be, calculate the area of the whole pool. Okay, in other words, the whole area within the fence. Second question, calculate the area of the pool. Third question, now calculate the area that needs to be grassed. How would I do this, folk? I would go ahead and I would say, right, first of all, the area of the pool, or the area of the whole pool fenced area, is going to be length times breadth, because we're dealing with a rectangle. My length is 18 meters and my breadth is 15 meters. We multiply that out and we say 18, multiply that by 15, and I get 270 meters squared. Now, what's the area of the pool? Well, were I to take a nice little line here and draw a line across across, I can actually see that what I now have is I have a rectangle and I have a semicircle. So the area of the pool is going to be the length times the breadth, which is this part, plus the semicircle. So plus pi times r squared times a half. Area here, 12 times 5 plus pi, which is 3,142, multiplied by the radius. Now, folks, what is this line? If that's 9 and that's 12, I know this line is 3 meters, but that's the diameter. So the radius must be 1.5 meters, and I'm going to square it, and then times a half. So now let's fill in all these weird and wonderful answers. 12 fives we know are 60 meters squared, plus I'm going to say I've got 3,142 times 1.5, and we're going to square that, multiplied by a half, or 0.5, and there's my answer. It's going to be 3,53 meters squared. We add those together, 63,53 meters squared. So I found the area of this entire fenced part. I found the area of the pool. So now, what area needs to be grassed? Well, this is going to be easy. All we're going to do then is take the grass area, is going to be that total area, 270 meters squared, and we're going to subtract the pool, because we don't want to put grass in our pool. Okay, that would be kind of weird if we cover the pool with grass. So out comes the calculator, and we say 270 minus 63.53 equals, and I'm going to get an answer of 206,47 meters squared. Right, we're going to take a break, and then we're going to come back and do one or two more little areas to do with problem. We'll see you soon.